Hello, welcome to CSC 8025, Computer and Network Security. My name is Brady Chen. I'm from Department of Computer Science at Fitchburg State University. So the course consists of many modules which cover the fundamentals of number theory, authentication and encryption and decryption technologies, as well as some of the well-known security-related topics. And it also covers some well-known encryption and decryption algorithms widely used in industries. Module 1, Information and Network Security Concepts. Now, in this module, we will first define many of the terminologies used in the information and the network security. We'll then provide the overview of the main areas of network security and the cryptographic algorithms. Okay, so now we're going to discuss the remaining learning objectives in Module 1B. So in 1A, we discussed the key security requirements like confidentiality, integrity, and availability, the CIA triad. And then we also discussed the type of security threats and attacks. Now, in 1B, we're going to provide the overview of the main areas of network security. And also, we're going to provide an overview of keyless, single key, and the two-key cryptographic algorithms. We're going to talk about the various different cryptographic algorithms. And then we're going to describe the trust model for information security. And lastly, we're going to list and briefly describe key organizations involved in cryptography standards, okay, such as ITU-T and the other organizations. Okay, so in Module 1A, we talked about the security requirements. Now, for example, like confidentiality, integrity, availability, and these three are known as the CIA triad. We also added authenticity and accountability. A security service is a capability that supports one or more of the security requirements. So now, the security services actually achieve these, goal by implementing the security policies and also by implementing the security mechanisms we just talked about in the previous Module 1A. Now here, we list the security services, some of the security services, like authentication, access control, data confidentiality, data integrity, and non-repudiation, and also availability services. We're going to discuss each of these in details. Okay, let's first talk about authentication service. Authentication concerned with assuring that a communication is authentic. There are two scenarios. In the first case, in the case of a single message, authentication assures the recipient that the message is from the source that it claims to be from. That's in a single message case. Now, in two communications, in the case of ongoing interaction, authentication assures that the first two entities are authentic, which basically means that each is the entity that it claims to be. So that's one. Two, the connection is not interfered with in such a way that a third party can masquerade as one of the two legitimate parties. Okay. In ITU-T X.800, two specific authentication services are defined. The first one is peer entity authentication. And then the second one is the data origin authentication. We're going to talk about these two in the next slide. So the first authentication service is the peer entity authentication. Now, peer entity authentication provides for the corroboration of the identity of a peer entity in an association. So now, two entities are considered peer if they implement the same protocol in different systems. So peer entity authentication is provided for use at the establishment of or at the time during the data transfer phase of a connection. Okay, so for example, during the connection between two entities, so people use this three-way handshaking or any kind of mechanisms. Now, these are the peer entity authentication service. Now, peer entity authentication service attempts to provide confidence that an entity is not performing either a masquerade or an unauthorized replay of the previous connection. Okay, that's the peer entity authentication. Now, second one is the data origin authentication. Data origin authentication provides for the corroboration of the source of a data unit. Okay, so it does not provide protection against duplication or modification of data units. Okay, so basically, this type of services support applications like email. Well, there are no ongoing interactions between the communication entities. It's just a one-way connection. Now, the next authentication services is the access control. Now, an access control is the ability to limit and control the access to host systems and applications via communications link. Okay, so typically to achieve this, each entity trying to gain access must first identify or authenticate so that the access rights can be tailored to the individual. So typically they use like the password or some kind of key to gain access. Okay, so the data confidentiality service is the protection of transmitted data from passive attacks. Okay, it can apply to a string of message, a single message, or a selected field within the message. Now, in the second and the third case, these are also called narrower forms of the data confidentiality service. Now, the broadest service protects all user data transmitted between two users over the period of time. For example, when a TCP connection is set up between two systems, now these broad protection prevents the release of any user data transmitted over the TCP connection. Now, throughout the whole connection. Okay, so this is the data confidentiality service. Now, the other aspect of that confidentiality is the protection of traffic flow from analysis. Okay, the protection of traffic flow. Now, this requires that an attacker not be able to observe the source and the destination, frequencies, length, or the other characteristics of the traffic on the communication facilities. Now, one of the examples of this is the like a VPN, the Virtual Private Network Service. The VPN actually prevent the attacker from observing the source and the destination, or even like doing the traffic flow analysis. So the next service is the non-repudiation. Non-repudiation prevents either sender or receiver from denying a transmitted message. So there are two meanings. Okay, first, when a message is sent, okay, the receiver can prove that the alleged sender in fact sent the message. So when someone just sent the message to you, and then he or she just regretted it, he just tried to deny it, so I did not send the message, and then the receiver, in that case, you can prove that he did actually send the message. Now the other scenario is that when a message is received, that the sender can prove that the alleged receiver in fact received the message. Okay. Now this service is very important, particularly when you send some kind of legal documents. Okay. When you send the document and the receiver just pretend that oh, I did not receive your message, sorry, and then with the non-repudiation service, then you can actually provide proof that yes, you did receive the message. Okay, you cannot deny that. Okay, the next one is the availability service. Availability service protects a system to ensure its availability. So availability is the property of a system or a system resource being accessible and usable upon demand by an authorized entity, authorized users, according to the performance specification for the systems. So typically it's actually written in a contract. When you sign up upon the contract, if the availability service is provided, then that means, it should be guaranteed. So, or in another word, a system should be available if it provides services according to the system design whenever user requests them. Okay, so this service addresses the security concerns raised by denial of service attacks, because the biggest threat to the availability service is the denial of service attacks. Okay, you have to address this concern. And also, availability service depends on proper management and the control of system resources. Okay, and thus depend on the access control service and the other security services. Okay, so far we have discussed security attacks, like a passive attacks or active attacks. And also we discussed the security services in OSI security architecture. Now, we will take a look at the security mechanisms. Okay, so recall that the security services are implemented by security mechanisms. If you actually go back to the previous slides, you will find out we just mentioned that. Okay, in some case, the one security service may be implemented by one or multiple security mechanisms. Okay, now here the most important security mechanisms are listed. Okay, we will discuss each of these in much details. Okay, one of the security mechanisms is the cryptographic algorithm. Okay, but before we talk about the cryptographic algorithms, we first need to introduce the term which is called cryptography. Cryptography is a branch of mathematics that deals with the transformation of data. Now, it's part of the number theories in math. Okay. Cryptography is an essential component in the secure storage and the transmission of the data. So in the next slide, we're going to talk about the various different type of algorithms, the cryptographic algorithms. Okay, So cryptographic algorithms can be divided into 3 categories. Okay. So the first category is the keyless. Okay. The keyless cryptographic algorithm. There are 2 examples. Here are 2 examples. First is the hash function. Okay. And the second one is the pseudo random number generator. It's more like a math function who can actually create some numbers. It looks like a random number, but it's actually not. It's a pseudo random number generator. Okay. Now the second category is the single key cryptographic algorithms. Now single key algorithms are mostly called symmetric encryption and decryption. Okay. So 3 examples are block cipher symmetric encryption, and a string cipher symmetric encryption, and a message authentication code. Okay. So block cipher symmetric encryption are mostly used in the two-way communications. Okay. In that case, 2 parties use the same private key. Okay. And mostly they use the same algorithm, encryption and decryption algorithm. Now string cipher is actually, basically two party basically when they keep sending the messages. Okay, for example, the communication between the computer and a router in the Wi-Fi, they use the string cipher. And the third category is the 2 key, and many times it's called public key encryption decryption algorithm. Okay. So in that case, typically there are 2 keys. Okay. One is called a public key. The other one is a private key. Okay. So in this case, the sender may use the private key to encrypt the message, and the receiver may use the public key to decrypt the message, or vice versa. So sender use the public key to encrypt the message, and then the receiver use the private key to decrypt the message. Okay. Now here are 4 examples of the 2 key algorithms. Asymmetric encryption and digital signature, which is very useful to send some kind of legal document, and a key exchange algorithm, and the user authentication. So we can talk about all these in the follow-up modules. Okay. Okay, so first, the keyless algorithms. The keyless algorithms are deterministic functions that have certain properties useful for cryptography. Okay. Now, as we mentioned, that the one type of keyless algorithm is the cryptographic hash function. Okay. Now, basically, a hash function turns a variable amount of text into a small fixed length value called hash value, or hash code, or digest. Now, how are we going to use the hash function? Mostly, hash function is going to be used with the other encryption algorithm. So when we send a message to the receiver, when I send a message to my destination, okay, so I encrypt the message, but I also, apply the message using the hash function, and also I attach the hash value, okay, with the message. So when the receiver receives it and decrypt the message, they can check, use the hash function to check whether this message has been modified or not. So that's something we're going to talk about later, okay? And the other keyless algorithm is the pseudo random number generator. Okay, so pseudo random number generator produce a deterministic sequence of numbers or bits that has the appearance of being a truly random sequence. It's not actually a random sequence, but it looks like a truly random sequence. Okay, now let's discuss the second category, the single key algorithms. Now, single key cryptographic algorithms depends on the use of a secret key. Okay, so these encryption algorithms that use a single key are typically referred to as a symmetric encryption algorithms. Now, in this encryption algorithms, both parties use the same private key. Okay, let's say we have a sender and we have a receiver. And here is the key. It's a secret key. Okay, it could be a sequence of numbers. Okay, and so here's the plain text. Okay, it's unprotected. Okay, now then we're going to apply the encryption algorithm, okay, by mixing the plain text with the key. Then we're going to generate unintelligible, message. Okay. So it's called ciphertext. Okay. Ciphertext is unintelligible. Okay. Now, then we send out this message through the internet. So internet itself is not protected, but this message is protected by the key, right? So when the receiver receives this ciphertext, which is protected, receiver cannot read it until receiver use the decryption algorithm. So here's a ciphertext, combined with the key. The ciphertext combined with the key, and then it can generate the plain text. You're going to restore the original text. Okay. So in this case, both parties use the same key, and mostly both parties are going to use the same algorithm. Encryption and the decryption algorithm could be the same algorithm. Okay, the symmetric encryption takes the following two forms: the block cipher and the string cipher. Okay. So a block cipher operates on data as a sequence of blocks. So that means if we want to send a message, we call this message a plain text message. Okay. And then we're going to divide the original message into blocks, typically of the same size. We call the first block the P1, P2, second one, P3. Okay. Now, the algorithm basically takes the blocks. Okay. Let's first say take the first block P1, and also take the key. Okay. So it takes the first block and the key, which is also a sequence of digitals, and then you're going to generate the block called a cipher, which is a ciphertext, and then we call this block C1. Okay. Now, next, you're going to take the second block P2, mixed with the key, which is the same key. Okay. And generate C2. And then we continue to do this. So eventually, we're going to generate a sequence of blocks of ciphertext. So then we're going to send out these. We concatenate the ciphertext C1, C2, C3, and then so we're going to send out these, messages. So the decryption is pretty much similar. So the algorithm takes the C1 and mix it with the key, and then restore to the original block, P1. Okay. And this actually process continues. Now, there's a variation of the block cipher. That means sometimes the block cipher may actually take the block. For example, let's say the first one is P1. P1 mix with the key and generate ciphertext C1. Now, in the second case, P2, okay, you're going to mix it with the key and also mix with the C1, the previous ciphertext, the previous blocks of ciphertext, and then generate C2. So basically, C2 contains the information of P2, the plaintext 2, the block of plaintext, and the key, and C1, which is the ciphertext of the previous block. And this way, we're going to continue to do that. So, for example, if we have a P3, and then we mix it with the key, okay, and combine the information of C2, and then we generate C3. Okay. So these are the two variations of the block cipher. Now for the string cipher, a string cipher operates on data as a sequence of bits. Okay, let's say we have the plaintext. And the plaintext, let's suppose that we operate, the plaintext is going to be stored as binary bits. So it's a sequence of binary numbers: 1 0 1 1 0 1 1 1 0 0 1 0 1. Okay, so that's a plaintext. So the algorithm gonna take the plaintext bit by bit. Okay, so that means you're gonna take the first bit 1 and mix with the first bit of a key, and we call this key string. Okay, so the key will be in the form of string. So the first bit of the plaintext is going to mix with the first bit of key string and generate another string. It could be 0 or could be 1. I don't know, depend on the algorithm. And then, so we generate one bit. Let's say 1. Okay, that's the first. And then the algorithm take the second bit 0 and mix with the second key bit in a key and generate the next one. Let's say also 1. So then you can actually continue. Take the third bit of the plaintext and the third bit of the key string and generate this third bit. Okay, now if we continue, then we're going to generate a sequence of binary numbers, and that's the ciphertext. Okay, now how we're going to actually generate the key string, that's the issues we're going to talk about in the follow-up modules. Because initially, even with the string cipher, we're going to actually import the key. The key is actually limited. It could be like a 64-bit. It's not going to be like a very long line, a long key string. So once we got a key, then we can actually use the algorithm to generate the key string. Okay, how long is the key string? It could be as long as the plain text. Okay, so another form of the single key cryptographic algorithm is the message authentication code. It's called a MAC, which is widely used in PC. Now with MAC, when you create a MAC, you basically combine the secret key. Okay, with the message. Okay, with the message, and you want to protect. So that information then is hashed. Okay, you're going to go through the hash function. It's hashed as a fixed length, and creating a string of data that serves as your MAC. Okay, once this is done, your message is sent. Okay, and it makes its way to the recipient, and then the client then compute the MAC using the same function, and then compare them. So that's the other way. We can talk about this later in much detail. Okay, so let's talk about 2 key algorithms. 2 key algorithms involve the use of 2 related keys. One is the private key, the other one is public key. A private key is known only to the single user or entity. Now in the meantime, the public key is made available to number of users. Okay, it's made available to public. Okay, now because of this, 2 key algorithms are typically called, asymmetric encryption-decryption algorithm. Okay, now the asymmetric encryption or the decryption can work in 2 ways. Okay, now let's say here's the message. Okay, a plain text message. Okay, now here's the encryption algorithm. Now in the first case, so the plain text is going to be combined with the private key. Okay, and then you're going to generate a ciphertext. Okay, which is unintelligible. Okay, and then on the receiving side, the decryption algorithm is going to take the ciphertext and the public key to generate, or to restore to the original plain text. Okay, so the second way is the encryption. Encrypt the plain text using the public key. Okay, so you're going to generate an intelligible ciphertext, and then on the decryption side, you're going to decrypt it using the private key. Hopefully, we can restore back to the original plain text. So these 2 algorithms, these 2 actually ways basically will create various different effects. You're going to solve a different kind of problems. We're going to talk about this later. Okay. Okay, so here are some of the applications of a 2 key algorithm. Okay, so the first one is the digital signature algorithm. a digital signature is a value computed with a cryptographic algorithm and associated with the data object, like data message or paragraph, in such a way that any recipient of the data can use the signature to verify the data's origin and integrity. Okay. Now, the function of this digital signature perform exactly the same way as the traditional, signature. For example, when you receive a document, you check the signature, and then you can verify, okay, this is the document which is actually really signed by some person. Okay. So, using data signature, the signer of a data object use the signer's private key to generate a signature. And then anyone in possession of the corresponding public key of the signer can verify the validity of the signature. So it's basically used, the signature basically just like here's the signature, right? And then here's the encryption algorithm, and then basically it uses signer's private key to encrypt the signature to get the encryption ciphertext. And anyone who has the public key of the signer can decrypt it, and actually you can, he or she can view the signature. Okay. Now you can verify this by, if you use the public key of the signer and you can actually see the signature, that means this signature is, valid. Why? Because only the signer has the private key. Okay. So if you can use the signer's public key to decrypt it, so that means the signer must use his or her own private key to encrypt the message. Okay, so this is called digital signature. Okay. Now the another application is the key exchange. Okay. The key exchange is the process of securely distributing the system symmetric key to two or more parties. So in that case, we basically use the asymmetric algorithms, the two key algorithms, to communicate the symmetric key used in single key algorithm. Okay. Now we don't use the two key algorithms to send messages, the payload, but we use this to exchange the key, and then use the key for single key algorithm. Okay. Why we want to do this? We'll talk about this later. In general, the two key algorithm is any two key algorithm is very slow and not very efficient, but it's very secure. But in a single key algorithm, it's very fast. So that's the reason why we combine these two algorithms. Use the two key algorithm to exchange the key for single key algorithm. Okay. Now the other application is the user authentication. Now user authentication is the process of authenticating that the user attempting to access the application or service is genuine, and similarly the application or service is genuine. So we can talk about all this in the follow-up modules. So let's talk about network security. Now typically network consists of two parts: the device and also the network connected to these devices. So that's the reason why the network security is a broad term that encompasses two things. One is the communication security, which basically guarantee that the messages between two devices are secure. Now the other one is device security. Make sure that you protect the device from the intruder who wants to gain access and perform some kind of malicious action. Okay. Now, let's first take a look at the communication security. So the communication security is primarily implemented using the network protocols, like a TCP or IP. Okay. A network protocol consists of the format and the procedures that governs the transmitting and receiving of data between 2 points in the network. Okay. Now, with respect to the network security, a security protocol may be enhancement that is part of the existing protocol. They build into the network protocol, or a standalone protocol. Okay, like a protocol created by a third party. Okay. Now the second one, the other aspect of the network security is the protection of network devices. So these devices include routers, switches, the end systems such as the client system and the server system. Okay. So the primary concerns are intruders that gain access to the system to perform unauthorized actions, like insert some kind of malicious software, we call this malware, or overwhelm the system resources to diminish availability. So the some of the security mechanisms are in the network protocol. These are like IPsec and HTTPS. The secure HTTP is not HTTPS. Okay, and SSH. So there are various different network protocols. And some of the like a standalone protocol could be some kind of algorithm implemented using the cryptographic algorithms, like this keyless, single key or two key algorithms. Okay, for the device security, these are the three types of device security we typically talk about: the firewall, intrusion detection, and the intrusion prevention. So these will be talked about in details later. Okay, so in this last slide, we're going to talk about the various different standards defined by these different organizations, including the standards for the security, okay, the cybersecurity. Now, we actually mentioned a couple of documents like X.800. These are documents that are created by the International Telecommunication Union Telecommunication Standardization Sector. It's ITU-T. Okay, so this is the organization under the United Nations. Okay, so the International Telecommunication Union, ITU, is an international organization within the United Nations system, okay, in which the government and the private sector coordinate global telecom network and services. Okay, now the other organization is the International Organization for Standardization. Okay, so this is the worldwide federation of national standard body for more than 140 countries, one from each country. Okay, ISO is a non-governmental organization that promotes the development of standardization and related activities with the views of facilitating the international exchange of goods and services and to develop the cooperation in the sphere of intellectual, scientific, technological, and economic activities. So many actually products made by different manufacturers, they follow the ISO standard. So that means it complies with the ISO standard. So they can be used in many different countries. Okay. Now the other two organizations are, one is the NIST, the National Institute of Standards and Technology. Okay. Now this is the organization that makes most of the security-related standards, including the security mechanism and security algorithms. So some of the most important encryption-decryption algorithms are defined by the NIST, like a DES, Digital Encryption Standard, and AES, okay, Advanced Encryption Standard. So these are widely used worldwide. Okay. Now, the fourth one is the Internet Society. ISOC is a professional membership society with worldwide organization and individual memberships. It provides leadership in addressing issues that confront the future of the Internet, and is the organization home for the groups responsible for Internet infrastructure standards, including the Internet Engineering Task Force, IETF. Remember, one of the document, RFC 4949, that was a document created by IETF. Okay, and the Internet Architecture Board, IAB. Okay. So that's pretty much all we're going to talk about for the module 1. Okay. Okay, thank you.